Hi everyone. Today I will show some tricks about the LTspice for the experiment 2 of the METU course EE281. So let me share screen. So you can see my LTspice screen. And I'm opening a new schematic. And today I will show the AC voltage source, reading RMS value, and XY mode for the LTspice. So let's start with an example to adding the AC voltage source. I'm coming to component tab and one left click, and the selection screen is coming. So I will write here voltage source. So this is the voltage source, and I can set this voltage source what I need, as you see. So I'm selecting this one and putting my schematic. So when I right click on this source, I receive a new window. So I'm click the advanced, so I can select my voltage source specification. For example, I can select sine wave. So if I select sine wave, I can set my sine wave voltage source specification. So DC offset value I will assign a 0 volt. So amplitude I will select, for example, 5 volt. This means that my signal, sinusoidal signal, goes up to 5 volt and goes down to -5 volt. So I can select the frequency. For example, I will select 50 hertz. I don't want any delay, any phase difference cycles. So I will remain empty blocks. So, and then in this side, there is some parasitic properties. So I do not need parasitic effects. So I can select is 0 and 0. So when I click OK, my sinusoidal voltage source is created in my screen. So for continuing, let's construct a circuit. For example, I will put resistors in here, and I will put a capacitor in here. So I can wire connection. With then left clicks. Please don't remember adding the ground to the circuit within this way. So my circuit is ready, but the values of the components is not determined. So I can assign a 100 ohm for this resistor, and I can assign a 0.01 farad for the capacitor. So when I push the run button, it asks how can I do analysis. So the stop time is 1 second. Time to start saving data is 0, and maximum time step is 0.001 is enough. So when I click, it creates the analysis code. So when I click the OK button, it did the analysis. So I want to see the capacitor current and voltage. So when I come to capacitor, you can see the capacitor current, and when I come to the node, when I left click, you can see the red one, the voltage of the capacitor. So I want to read the RMS values of these quantities. So when I come to the, for example, the capacitor current, this is the I, in parentheses C1, this is the capacitor current, the green one. So I am pushing the control button in my keyboard and left click. So you can see the RMS value of the IC1. The capacitor current is 10.86 amp. This is the RMS value from 0 second to 1 second. So when I click the, I want to see the RMS value of the voltage. Again, I am coming on the voltage, and I am pushing the control button again in my keyboard and left click. So you can see the RMS voltage of the capacitor is the 3.46 volt. So let me see my notes. So you can see the voltage and current of the capacitor, and as you see, there is a phase difference between them. Both of them is sinusoidal signals, but there is a phase difference between, because the current peak point is here, and the voltage peak point is here, and there is not match. There is a small phase difference between them. So let's go to the XY mode. So first of all, I want to telling about the XY mode. XY mode means that there is no time data in the XY mode, time data. So in the, for example, imagine a graph. This is in the graph there is a y-axis and x-axis. So if you put the voltage on the y-axis, and if you put the current on the x-axis, so you get rid of the time data. This means that when the voltage is, for example, I am zooming the some of the parts. Yeah. When you look, for example, the current value of the capacitor is here. So let's look. If the capacitor current is 16 amp, for example, in here, 16 amp, what is the voltage value? When I comes here, the voltage value is nearly, for example, 0 volt. Let's see the, for example, 8 amp. When you come to 8 amp, 8 ampere for the capacitor current, so you can see the voltage level is here, and we can see this is the 4 volt. So let's go to the XY mode. For this one, I am coming to time axis with my mouse and right click. When you come to right time axis and pushing the right click, there is a window coming, and here I will write, for example, I want to x-axis is will be current of the capacitor, so I will write here I C1. I will write this notation to the here. So when I click the OK button, you can see the XY mode here. When you read the XY mode, for example, your capacitor current is 4 amps, is here. Your capacitor voltage will be nearly 5 volt, maybe 4.9 volt is here. For example, your capacitor current is 8 amp, and you can go to the 8 amp is here, and your capacitor voltage is nearly, you can see the 4 volt. Remember, just previously we read the 8 amp capacitor current goes to 4 volt capacitor voltage, as you've seen here. This is the XY mode. For closing this tab, you can close this one, and you can run the simulation again, and you can select current and voltage, and also you can go to the XY mode here when you come to the x-axis and right click, and this is writing default time, so you can delete it and you can write here I C1 and click the OK button, and you can see the XY mode again. That's all for today. I'm seeing my notes, and there is no any tricks about it. Also, you can assign the XY mode inversely. For example, I am coming to here the x-axis and right click for instead of time. I'm writing here, for example, I'm writing the voltage of the capacitor, so V, and in the parentheses this is the node name, so N001, and I'm pushing the OK button, and for this time the x-axis is voltage of the capacitor, and y-axis is current of the capacitor. It can be obtained by inversely. So I am adding the capacitor in the circuit because to seeing the XY mode exactly within clearly. So if I delete the capacitor, the phase difference is goes, so there will be no phase difference, current and voltage. So resistor is a passive element, so there is no phase difference between them. I am running the simulation again, so I am looking the resistance, current, and voltage. So they are exactly match. So the voltage and current is the same phase, so there is no phase difference between them. So I can again coming to x-axis and right click. So instead of time, I'm writing here resistors current for this example, I R1. So I am pushing OK button, and you can see there is no any circular XY mode. There is a straight line graph. So the x-axis is resistor's current, and y-axis is the resistor's voltage. So because of the they are in same phase, the simulation is resulted straight line graph. That's all for today. I think you can do your experiment too with using this video. Have a nice day. Thank you. I'm closing. Stop share.